Okay, let's go through the classwork on correlation and regression in Minitab. You're going to want open the 292 classwork document that I've attached to this video, as well as the Minitab file. And if you have it open, you should see income occupied and then cost age and so forth. All right, so we're just going to gradually work through these problems, and this classwork is really good. It's going to be laid out very similar to the homework and the quiz on the types of questions I can ask. All right, so let's start with income occupied. A suburban hotel derives its revenue from its hotel and restaurant operations. The owners are interested in the relationship between the number of rooms occupied on a nightly basis and the revenue per day in the restaurant. All right, so before we get started, let's think about what's our X and what's our Y. Okay, so what do we want to predict? All right, so here we want to predict revenue. All right, so that's going to be our Y, and the number of rooms occupied will be our X. All right, usually when it comes to the quiz and the exam especially, I try to make it abundantly clear of what is being predicted or explained. All right, so part A, does any kind of relationship exist between income and number of rooms occupied? All right, we want a scatter plot. All right, so to do a scatter plot, we go into graphs, scatter plot. We want a simple scatter plot, and income is our Y and occupied is our X. We say okay. And looking at this scatter plot, what might we say? So our options here are positive linear, negative linear, non-linear, and no linear correlation. So I would probably call this positive linear. You know, it's not obvious. It's not an exact science, but based on the trend here, I would call this positive linear. All right. Determine the correlation coefficient between the two variables and interpret the value. All right, so we want the Pearson correlation coefficient. So we go into regression correlation. Again, if you're working on a PC, correlation's up here in the main menu. Mac users, it's under regression. All right, so we go to correlation and put in income and occupied and say okay. All right, and here is our correlation coefficient. So to correctly answer this problem, we are going to say R equals 0.422978. We never round these. All right, and since that is slightly above that 0.4 cutoff, what are we going to say here? We're going to say this is a moderate positive linear relationship. All right, so we'll call this moderately positive. All right, what percent of the variation in revenue in the restaurant is accounted for by the number of rooms occupied? Report and interpret the coefficient of determination. All right, so we want the coefficient of determination here, that's R squared, and we need to run the regression in order to find that. So we're going to go into regression, simple regression. All right, income's our Y, occupied is our X, and we say okay. All right, so here is our R squared, this 17.89%. So we're going to come over here and say 17.89% of the total variation in restaurant income is explained by number of rooms occupied. Okay. D, calculate and report the regression equation using revenue based on number of rooms occupied. All right, so we want the equation, and we can look here in the coefficients table and get the coefficients, or we can scroll down a little further to where Minitab is actually typed out the regression equation for us, so we can come over here and say, and you can use X's and Y's, or you can use the words for the variables, income and occupied. I think I'll use the words just to make it easier for you guys. And again, we don't round any of these numbers, so income equals 1381.99 plus 1.4783 occupied. All right, test the significance of the slope. All right, so here's a hypothesis test. We're going to have to write our null and alternative. We're going to have to state the p-value, state the decision, and draw the conclusion. All right, so let's get started on that. We want to test the significance of the slope. So we're going to have slope, or beta, equals 0 versus an alternative of slope. And we need our symbol for not equal to. All right, and we want this p-value. All right, the p-value is in our coefficients table. All right, and it is the p-value on our x occupied, so that's 0.0351. All right, what's our decision? Since 0.0351 is less than 0.05, we reject the null hypothesis. All right, our conclusion is there is enough evidence to conclude the slope is significantly different from 0. All right, so in other words, the slope matters here, okay? The slope is significant. All right, what that means is that we want to interpret it. All right, so when it comes to interpreting the slope, the way we think about it is for each additional x, y increases by the slope. All right, so for each additional, what is x? So for each additional room occupied, the income increases by $1.48. All right, now why am I rounding here? Because it's money and we only go to cents. All right, so it doesn't really make sense here to say $1.4783. It makes more common sense to just simply round and say $1.48. All right, let's interpret the constant. Again, do we want to interpret the constant? Yes, we do, because the constant is significant, okay? So it matters to the problem. All right, so we want to interpret this 1381.99. All right, so how do we do that? When there are 0 rooms occupied, so when x is 0, y is the y-intercept. So when there are 0 rooms occupied, the restaurant income is $1,381.99. All right, use the regression equation to predict the income for 50 rooms occupied. All right, so how do we predict? All right, go under regression, predict for regression. All right, how many rooms occupied? We want 50, so we say okay. All right, and what are we looking for in the output? We are looking for the fit value right here under prediction, the 1455.90. So when there are 50 rooms occupied, we predict the restaurant income to be $14.55.90. Okay? And what you're going to see is we're going to do 3 more problems exactly like this. So I think that by the end of this, it's really going to click, and that what you should, approach the quiz with is, wow, this regression correlation stuff's pretty easy. All right, let's move on to cost age. I'm considering buying a fuel-efficient used car. The data represents several options with the estimated cost to purchase and the age of the vehicle. All right, what do we want to predict what? All right, well, obviously here, let's think about this. We want the age of the vehicle to predict the cost of the vehicle. All right, so does any kind of relationship exist between cost to purchase and age of the vehicle? So we go into graphs, scatter plot, simple. All right, our y is cost, our x is age. All right, so what do we see here? All right, and this should make common sense. What happens to the cost of a car as it gets older? It goes down. We know this. All right, so what we would say here for the scatter plot is negative linear. All right, determine the correlation coefficient between the two variables. All right, so we go into correlation, cost and age. All right, and so what we see here is that R equals negative 0.822403. So we would say here there is a strong negative linear relationship. All right, what percent of the variation in cost to purchase is accounted for by the age of the vehicle? All right, so again, we want R squared, or the coefficient of determination. So we need to actually run our regression. So we go to simple regression. We put in cost as Y, age as X, and say OK. All right, so here's our R squared, 67.63%. And so we say 67.63% of the total variation in cost to purchase is explained by age of the vehicle. All right, calculate and report the regression equation. All right, so we can scroll down here in Mini-tab and get our regression equation. All right, so we have cost equals 18,358 minus 1533.6 age. All right, test the significance of the slope. All right, we have the null is slope or beta equals 0 versus an alternative of slope or beta. Let's copy our not equal to. Not equal to 0. All right, we need our p-value. So we go to our coefficients table in Mini-tab and we look at age and scroll over to the p-value of 0.0003. All right, and since 0.0003 is clearly less than 0.05, we reject the null hypothesis. All right, so what does that mean for a conclusion? There is enough evidence to conclude the slope is significantly different from 0. All right, that means we can interpret the slope. It matters to the problem. All right, in other words, age is a good predictor of vehicle cost. All right, so we want to interpret this negative 1533.6. All right, so again, it's for each additional x, y changes by the slope. For each additional year older, the cost to purchase the vehicle decreases by $1,533.60. All right, interpret the constant. Well, again, we look in our coefficients table. The p-value on constant is significant, so we want to interpret the constant. All right, so what does the y-intercept mean for this problem? When the car is, and we don't say 0 years old, right? That just sounds bad. When the car is brand new, the cost to purchase is $18,358. All right, use the regression equation to predict the estimated cost for a vehicle 4 years old. All right, so we go into regression, predict for regression, and we are interested in 4 years old. We say okay. All right, and again, we're looking at this fit value, this $12,000 number. All right, and so we say when a car is 4 years old, we predict the cost to purchase to be $12,223.20. All right. So again, hopefully you're thinking, hey, this isn't too bad. All right, number 3. Harris Teeter is considering expanding into upstate South Carolina. As Director of Planning, you must present an analysis of the proposed expansion to the Operating Committee Board of Directors. As a part of your proposal, you need to include information on the amount of people in the region spend per month for grocery items. You would also like to include information on the relationship between the amount spent for grocery items and income. Does any kind of relationship exist between amount spent on grocery items and monthly income? All right, so what are we doing here? We're going to see if income predicts the amount spent on grocery items. All right, so let's do our scatter plot. All right, so again, our Y here is amount spent on groceries, and income is X. All right, and clearly this is positive linear, right? And it makes sense. The more income you have, the more you typically will spend on groceries. All right, so we're going to say here that this is positive linear. All right, determine the correlation coefficient. All right, so we go into regression and correlation, put in amount and income. All right, and we see that R equals 0.944744, which is a strong positive linear relationship. All right, what percent of the variation in amount spent for groceries is accounted for by monthly income? All right, so again, we want that coefficient of determination, or R squared. So we need to go into regression, simple regression. All right, amount is our Y and income is our X. All right, so we can see our R squared here of 89.25%. All right, so we have 89.25% of the total variation in amount spent on groceries is explained by monthly income. All right, calculate and report the regression equation. All right, so again, we can scroll down a little bit here in Minitab and we find our regression equation. All right, so what do we have? We have amount equals negative 74.37 plus 0.133875, and it's fine to just call it income. All right, test the significance of the slope. All right, so we've got a null of slope or beta equals 0 versus an alternative of slope or beta not equal to 0. All right, we want our p-value, and that's here in the coefficients table with income, and that is less than 0.001. All right, since less than 0.001 is less than 0.05, we reject the null. All right, and so there's enough evidence to conclude the slope is significantly different from 0. All right, that means we want to interpret the slope. That means that monthly income is a good predictor of monthly amounts spent on groceries. All right, so we want to interpret the slope. Again, that means for each additional X, Y increases by this amount. All right, so for each additional dollar in monthly income, the amount spent on groceries increases by 13 cents. All right, in other words, roughly you spend about 13 cents of every dollar on groceries. Okay. All right, interpret the constant. Well, we go to our coefficients table and we look, and constant has a p-value of 0.1697. That is not significant. That's bigger than 0.05. And so what we want to say here is, hey, the constant should be interpreted as 0. So when it comes to interpret the constant, we say we do not because it is not significant. All right. Use the regression equation to predict the amount spent for grocery items for a household monthly income of $5,000. All right, so we want to go into regression, predict for regression, type in 5,000. All right, and we're looking at this fit value here, this 595. All right, and so we say with a monthly income of $5,000, we predict the amount spent on groceries to be $595.01. All right, can you think of any other independent or explanatory variables that should also be considered in this model? All right, well, what else besides monthly income is going to predict how much money you spend at the grocery store? All right, so the first one that comes to my mind is number of people in household. You know, if it's just you, you're going to spend a lot less than if you're married with 5 kids, right? So number of people in household, I don't know. Maybe whether you're planning a party, something like that. And again, that's open-ended, so be creative and think of anything that might explain how much you spend on groceries. All right, last problem. Number 4. You are interested in whether or not distance traveled affects fare price for flights. Does any kind of relationship between distance and fare? All right, so distance traveled would be our X that we hope explains fare price. Okay? And again, if you're not picking up on what's X and what's Y, trust me when I say that I make it abundantly clear on the quiz and the exam using a word like, we want to see if this predicts this. Okay, so I'll actually use the word predicts. All right, so let's do our scatter plot. And we want to see if fare is predicted by distance. All right, so again here we clearly see a positive linear relationship. All right, so we're going to go over here and say positive linear. All right, and we want to determine the correlation coefficient, so we go into correlation, and we put in distance and fare. All right, and so we get R equals 0.65558. All right, so that's just below that 0.7 cutoff, so we're going to call this a moderate positive linear relationship. All right, what percent of the variation in fare is accounted for by distance? All right, so we want to interpret the coefficient of determination, or R squared, so we need a regression. So we go to simple regression. Fare is our Y, distance is our X. All right, and we see R squared here of 42.98%. All right, so we say 42.98% of the total variation in fare price is explained by distance traveled. All right, calculate and report the regression equation. So we can scroll down a little bit in Minitab and get our regression equation. All right, and so we just want to report that. All right, so we have fair equals 147.08 plus 0.05265 distance. All right, so now we want to test the significance of the slope. So we have a null that says slope or beta equals 0 versus an alternative of slope or beta not equal to 0. All right, we need a p-value, so we go to our coefficients table and we get our p-value on distance is less than 0.001. Since less than 0.001 is less than 0.05, we reject the null. Right, so there is enough evidence to conclude, oops, let's go back and fix 2, to conclude that the slope is significantly different from 0. All right, that means that distance traveled is a good predictor of fair price. All right, so we want to interpret the slope. All right, so again, for each additional x, y increases by the slope. So for each additional mile traveled, the fair price increases by a nickel. All right, what about the constant? Do we want to interpret it? We go over to our coefficients table. We look at the p-value on constant. It is significant, so we do want to interpret the y-intercept. All right, so when the distance traveled is 0 miles, the fair price is $147.08. All right, so I'm just going to put in parentheses here. I mean, you guys have probably taken a accounting class. This would be something like a fixed cost, okay? So this is just some base fare that the airline is charging regardless of the distance traveled. All right, use the regression equation to predict the fare for a 1,500-mile flight. All right, so we go into regression, predict for regression, put in 1,500. All right, and we look at our fit value, the 226 number here. So we say when the distance traveled is 1,500 miles, we predict the fare price to be $226.06. Okay, again, rounding there for it to make sense in terms of money. All right, so hopefully after these 4 problems, you're thinking this isn't too bad. You're definitely ready to go do the homework and then attempt the quiz. If you have any questions, just reach out to me.